Now before taking up the next type of integrals, we must memorize the following list of formulae. I have divided this list into set of 3 formulae each, and we must memorize them. First is 1 over a square minus x square dx is 1 by 2a log of a plus x over a minus x. And if we have 1 over x square minus a square dx, then 1 by 2a log x minus a over x plus a. If it is a square minus x square, this will be log of a plus x over a minus x. And if it is x square minus a square, it will be log of x minus a over x plus a. Rest form of both these formulae is same. 1 by 2a log a plus x over a minus x, and for this we have log of x minus a over x plus a. And third is x square plus a square, and for this we have 1 by a tan inverse x by a. Now with a square and x square, we have only this set of formulae: a square minus x square minus a square, and x square plus a square. Only these 3 formulae are possible. So integral of 1 by x square plus a square dx is 1 by a tan inverse x by a. And for both these we have 1 by 2a log a plus x over a minus x, and here we have x minus a over x plus a. And now we have 3 formulae for root of each of these terms. 1 over under root a square minus x square dx is sine inverse x by a. 1 by under root a square minus x square dx is sine inverse x by a. And for 1 over under root x square minus a square dx, we have log of x plus under root x square minus a square. Log of x plus this term. Log of x plus this term. And integral of 1 over under root x square plus a square is log of x plus this term. Here we have log of x plus this term. Here we have log of x plus this term. So for integral 1 over under root a square minus x square, we have sine inverse x by a. And for 1 over under root x square minus a square and 1 over under root x square plus a square, we have log of x plus this, log of x plus this. So you must memorize these sets of formulae. And when these terms are in the numerator, we have another set of 3 formulae. For under root a square minus x square dx, we have x under root a square minus x square by 2 plus a square by 2. For each of these formulae, the pattern is same. We have x into this by 2, x into this by 2 plus, if it is positive here, it will be a square by 2. X under root a square minus x square by 2 plus a square by 2. Here we will have x under root of this by 2 minus, because it is a minus a square. You can use this as an aid to memory. If it is plus a square, it will be plus. If it is minus, it will be minus. This can be used as an aid to memory. So integral of under root x square minus a square dx is x under root of this by 2 minus a square by 2. And in this case, we will have x into this by 2 plus a square by 2. And this will be the integral of the reciprocal. Integral of reciprocal of this is sine inverse x by a. So we will have sine inverse x by a here. And here reciprocal of this is this. And integral is this. So we will have log x plus under root x square minus a square. And here we will have reciprocal of this is this, and we will have log of x plus under root x square plus a square. So integration of the reciprocal will be written here. So pattern is easy to remember. X into this by 2 plus a square by 2, x into this minus a square by 2 into integration of reciprocal. So it is easy to remember the pattern. Pattern is x into this by 2 plus a square by 2 into integration of reciprocal. X into this by 2 minus a square by 2 and integration of reciprocal is log of x plus under root x square minus a square. And similarly in this case, x into this by 2 plus a square by 2 and integration of reciprocal of this is this. So now you can memorize these sets of formulae. Now I take up very simple questions first, which will illustrate how to use these formulae, and then we will take up some more questions. So I take up very quickly very simple formulae based on the above formulae. You can see the formulae on the side sheet. So first is this. So this can be written as integral 1 upon 2 square plus 3 square x square dx. And we can take 3 square common. So 3 square is common, so this will be 1 by 3 square integral of 1 upon 2 by 3 whole square plus x square dx. So this is equal to, now this is in the form integral 1 by a square plus x square, and formula for 1 over x square plus a square is 1 by a tan inverse x by a. You can see the side sheet. So this is 1 by 9 into 1 by a is 2 by 3 into tan inverse x by a, x by 2 by 3. So this is equal to, now this will go in the numerator, so this will be 3 by 2. So we will be left with 1 by 6. 1 by 6 tan inverse 3x by 2 plus constant of integration. This is the formula. And this can also be done as, you can write this as integral 1 upon 2 square plus 3x whole square dx. And this is in the form x square plus 1 over x square plus a square. And so you can directly write this as 1 by a, 1 by 2 into tan inverse x by a. X is 3x, 3x by 2. And we are using a formula for x for 3x. A formula for x is being used for 3x. So we must divide by the coefficient of x. So you can also do this question like this. So this will be 1 by 6 tan inverse 3x by 2, which is same as this, plus c. And this is equal to integral 1 upon 3x whole square minus 2 square dx. So this will be equal to 1 by 2a, 2 into a is 2, into log of x minus a, 3x minus 2 divided by 3x plus 2 plus c. That is 1 by 4 log of 3x minus 2 over 3x plus 2 into, and we must divide by the coefficient of x. We are using a formula for x for 3x. A formula for x is being used for 3x, so we must divide by 3. So this will be 1 by 3 plus c. So this is 1 by 12 log 3x minus 2 over 3x plus 2 plus c. And in this case we have this is equal to integral 1 upon under the root 2 square plus 3x whole square dx. And this is equal to now 1 over under root a square plus x square. Formula for integral 1 over under root a square plus x square dx is log of x plus under root a square plus x square. You can see the side sheet. So this is equal to log of x. So instead of x we have 3x. 3x plus under the root 2 square plus 3x whole square. And since a formula for x is being used for 3x, we must divide this term by 3. 3 plus c. So this is equal to 1 by 3 log of 3x plus under the root. Now this is same as this. So we can write 4 plus 9x square. 4 plus 9x square plus constant of integration. So this is the result. A formula for x is being used for 3x, so we must divide by 3. You should not forget to divide by 3. And in this case, we have this is equal to integral 1 upon under the root 3x whole square minus 2 square dx. And formula for integral 1 over under root x square minus a square is log of x plus this. Log of x plus under root x square minus a square. So this is equal to log of x. So we have 3x instead of x. 3x plus under the root 3x whole square minus 2 square. And since we are using a formula for x for 3x, so we must divide by 3. This plus c. So this can be written as 1 by 3 log of 3x plus under the root. Now this is same as 9x square minus 4. So this is 9x square minus 4 plus c. Now next is 9x square minus 4 under the root. What we do is we write this as integral under the root 3x whole square minus 2 square dx. So this is integral under the root x square minus a square. So integral of this will be x into under the root of this, that is 3x square minus 2 square by 2. And since a square is negative, we will have a square by 2, that is 2 square by 2 into integration of reciprocal of this. So integration of reciprocal of this is log of x plus under root of this. So log of x is 3x plus this. So this will be under root 3x whole square minus 2 square plus c. And since we are using a formula for x for 3x, so we must divide this whole term by 3. So this must be divided by 3. 1 by 3 coefficient of x. You must never forget to divide by the coefficient of x. If you are using a formula for x for kx, then you must divide the result by k. So this is equal to, this will be 1 by 6. So this will be 1 by 2x under the root 9x square minus 4. This is same as 9x square minus 4. Minus this will be 2, 4. This is same as 9x square minus 4. Minus this will be 2, 2 by 3. Open this bracket. 2 by 3. Log of mod 3x plus under the root 9x square minus 4 plus c. So this will be the answer. Formula for under root x square minus a square, you can see the chart sheet, is x into this by 2 minus a square by 2, and integration of reciprocal of this is log of 3x plus under root x square minus a square. And in this case, what we do is we first make a substitution. Put x cube equal to t, because differentiation of x cube is x square. So x square dx will go with dt. This will be the simplification part. X square dx will become dt, and this will be t square minus a to the power of 6. So this will reduce to one of these standard formulae on the side sheet. So this will be equal to I is equal to, let us say this is I. So I will be equal to integral, first we differentiate this. So this will be 3x square dx is equal to dt, and therefore x square dx is 1 by 3 dt. So I can be written as integral x square dx is 1 by 3 into dt, whole divided by x to the power of 6 will be t square, and a to the power of 6 we can write a cube whole square. So this is 1 by 3 dx over x square minus a square. Formula for this is 1 by 3 into 1 by 2a log of x minus a, that is t minus a cube over x plus a, that is t plus a to the power of 3. So we have 1 by 2a. So a here is a cube. And integration of this is 1 by 3 into 1 by 2a. So we have a cube instead of a. So we will write 1 by 2a cube log of x minus a over x plus a plus c. So this is equal to 1 by 3 into 1 by 2a cube log of, now instead of t we can write x cube. So x cube minus a cube whole divided by x cube plus a cube plus c. So this can be written as 1 by 3, 1 by 2a cube log of, instead of t we are writing x cube minus a cube over x cube plus a cube plus c. So answer is 1 by 6a cube log of x cube minus a cube over x cube plus a cube plus c. Now on similar lines you can try these questions. You try these questions yourself. I move on to the next set of questions. Now next type of questions is 1 over quadratic, 1 over root quadratic, or root quadratic. Integration of 1 over quadratic, 1 over root quadratic and root quadratic. So what we do in such questions is you must keep these keywords in mind. What we do is express Q as sum or difference of two squares. Express this quadratic as sum or difference of two squares and use appropriate formula. So we have to express the given quadratic as a sum of or difference of two squares and then use the appropriate formula. Now how to express this quadratic as a sum or difference of two squares, I will illustrate now. First example I am taking is 4x square plus 12x plus 5. Suppose this is the given quadratic. Now we express this quadratic as a sum or difference of two squares. So first step is what we do is we make the quotient of x square unity. Take 4 common, quotient of x square will be 1 plus 3x plus 5 by 4. Make the quotient of x square unity. Now to make this a complete square, what we do is this is x square plus 3x plus add and subtract half the quotient of x. Add and subtract half the quotient of x whole square. So half the quotient of x. Half the quotient of x is 3 by 2. 3 by 2 whole square will be added and 3 by 2 whole square will be subtracted. Plus 5 by 4. This can be written as x, and since this is x square plus 2ab plus b square. Since 2ab term is positive, we will write x plus 3 by 2 whole square. If this is negative, it will be x minus 3 by 2 whole square. Minus this is 9 by 4 plus 5 by 4. And this is equal to 4 into. This is x plus 3 by 2 whole square minus. Now minus 9 by 4 plus 5 by 4 is 1. This will be minus 1. So this is minus 1 whole square. Now we will use an appropriate formula depending upon the question. For example, if the question is integral 1 upon 4x square plus 12x plus 5. If the question is this, we will write this as 1 by 4 will be common, and we will write this as 1 upon x plus 3 by 2 whole square minus 1 square dx, and this is equal to 1 by 4 into integral of x square minus a square. 1 over x square minus a square is 1 by 2a. So 2 into a is 1. 1 by 2a log x minus a over x plus a. So instead of x we have x plus 3 by 2. So x minus a over x plus 3 by 2 plus 1. So this will be the formula used. And if it is, say, integral 1 upon under root 4x square plus 12x plus 5. If this is the question, then what we do is we will write this as integral 1 upon under the root. Now 4x plus 12x plus 5 can be written as 4 into x plus 3 by 2 whole square minus 1 square dx. And this can be written as 1 by root 4. Root 4 is 2. 1 by 2 integral 1 upon under the root x plus 3 by 2 whole square minus 1 square dx. So this is equal to 1 by 2 into, now formula for 1 by under root x square minus a square. 1 over under root x square minus a square is log of x plus under root of this. So this is x. X is x plus 3 by 2. You can see the side sheet. Plus under the root x plus 3 by 2 whole square minus 1 square. So this is x plus under root of this. This is the formula. So if question is like this, formula used will be this. If it is this, formula used will be log x plus under root x square minus a square. So procedure is same for all these types. Only at this stage you will have to use different formulae. If this root is in the numerator, then what we do is, suppose question is under root 4x square plus 12x plus 5 dx. If this is the question, then what we do? Now this can be written as, this is same as this. So this will be equal to 2 integral under the root, the term in the denominator. So 2 under root x plus 3 by 2 whole square minus 1 square dx. Now in similar way we will be able to write this as this and use appropriate formula. So appropriate formula for this will be under root x square minus a square. So x square minus a square is x, that is x plus 3 by 2 into under root of this, that is x plus 3 by 2 whole square minus 1 square over 2. This 2 will be common. This is common. Formula for this will be x under root x square minus a square by 2 minus, we have minus with a square, so we will have minus a square, and a square is 1 square. 1 square by 2 into integral of its reciprocal, and integral or reciprocal of this will be log of, see, x plus 3 by 2 plus under the root x plus 3 by 2 whole square minus 1 square. So this will be the result. You can simplify this. I am only demonstrating how to express this as sum or difference of two quadratics and use appropriate formula. How to use appropriate formula. If this reduces to this form, formula will be this. If it reduces to this form, formula used will be this. Method will remain same. And if it is under root quadratic, the formula used will be this. Only difference will be which formula will be used. So now I move on to the next example. How to express a quadratic as sum or difference of two squares. Now next I consider this example. 3 minus 2x minus 2x square. Now first step is make the coefficient of x square unity. So we write this as minus 2x square minus 2x plus 3 and take the coefficient of x square common. That is minus 2 will be taken common and we will have x square minus 2 is common, this will be plus x, and minus 3 by 2. So first we make the quotient of x square unity. Now second step is add and subtract half the quotient of x whole square. So what we do is this will be minus 2 into x square, and half the quotient of x is 1 by 2. 1 by 2 whole square will be added and 1 by 2 whole square will be subtracted. Minus 3 by 2. So this is equal to minus 2 into, now this is a square plus 2ab plus b square. So this is a is x and b is 1 by 2. And if we expand this, we will get x square plus 2ab. 2ab will be x. 2 into x into half. It will be x plus b square. So this is x plus half whole square. And simplify this. This will be minus 1 by 4 minus 3 by 2. So this is equal to minus 2 into integral x plus 1 by 2 whole square minus. Now take LCM. LCM is 4. So this will be minus 7 by 4. Multiply and divide this by 2. So this will be 6 by 4. So 6 by 4 minus 1 by 4. This is 7 by 4. And this can be written as minus 2 into integral of x plus 1 by 2 whole square minus root 7 by 2 whole square. So this quadratic has been expressed as difference of two squares. What we in questions we will do, we will take this minus inside, and this will be root 7 by 2 whole square minus this, and use appropriate formula. So this is how we express a quadratic as sum or difference of two squares, and how to use appropriate formula. Now I move on to the questions. Now first question is this. Now this is 1 over quadratic. So we express this quadratic as sum or difference of two squares. So what we do is we write 4x square plus 12x plus 5 is equal to. Take 4 common. 4 is common, so quotient of x square will be unity. Plus 3x plus 5 by 4. So this is equal to 4 into x square plus 3x plus half the quotient of x. Add and subtract half the quotient of x whole square. So this will be half the quotient of x is 3 by 2. 3 by 2 whole square will be added and 3 by 2 whole square will be subtracted. Plus 5 by 4. Add and subtract half the quotient of x whole square. So this is equal to 4 into x square plus 3x plus this is 3 by 2 whole square minus 9 by 4 plus 5 by 4, and this is equal to 4 into, now this is x plus 3 by 2 whole square. 2ab term is positive, so x plus this, a plus b whole square. A square plus b square plus 2ab, 2ab is 3x, minus this will be 1. So we can write this as 1 square. So this integral can now be written as I is equal to integral 1 upon 4 into x plus 3 by 2 whole square minus 1 square dx. And this is equal to 1 by 4 integral 1 upon x plus 3 by 2 whole square minus 1 square dx. So formula used will be 1 upon x square minus a square. And this is equal to 1 by 4 into. Now this will be 1 by 2a. 1 by 2a into log of x minus a over x plus a. So this will be x plus 3 by 2 minus 1 over x plus 3 by 2 plus 1 plus constant of integration. So this will be 1 by 8 into log of, now take the LCM. So this will be LCM of both numerator and denominator is same. So it will cancel. So we will have 2x plus 3 minus 2. 3 minus 2 is 1. Whole divided by, this will be 2x plus 3 plus 2. 3 plus 2 is 5. This plus c. So this will be the answer. So we have expressed this quadratic as difference of two squares and have used appropriate formula. Now we move on to the next question. So here x square plus 6x plus 13. This can be written as, now quotient of x is already 1. So we will move on to the next step. That is x square plus 6x plus half the quotient of x. Half the quotient of x is 3. So we will add 3 square and subtract 3 square plus 13. So this will be x plus 3 whole square. This is 9. 9 plus minus 9 plus 13 is 4. So this will be plus 4. So this can be written as x plus 3 whole square plus 2 square. So this integral will be equal to, I is equal to integral 1 upon x plus 3 whole square plus 2 square dx. Now formula used will be 1 over x square plus a square. Express this quadratic as sum or difference of two squares and use appropriate formula. So appropriate formula in this case will be 1 by a. 1 by a is 1 by 2. Tan inverse x by a. So x plus 3 by a plus c. So this will be the. Now next question is this. So what we do is x minus 1 into x minus 2 is equal to. This is x square minus 3x plus 2. And this can be written as x square minus 3x plus half the quotient of x, that is 3 by 2 minus 3 by 2 whole square minus 3 by 2 whole square plus 2. This is only to indicate that b is minus 3 by 2. This is equal to x minus 3 by 2 whole square minus. This is 9 by 4 plus 2. And this is equal to x minus 3 by 2 whole square minus. This is 8. 8 minus 9 is minus 1 by 4. And this can be written as x minus 3 by 2 whole square minus 1 by 2 whole square. 2ab term in this case is negative. So we have a minus b. It is also being indicated here. And therefore I will be equal to, I is equal to integral 1 upon under the root this. This is x minus 3 by 2 whole square minus 1 by 2 whole square dx. So we will now have to use the appropriate formula, and appropriate formula will be 1 by under root x square minus a square. So 1 over under root x square minus a square will be log of x minus 3 by 2 plus under root of this. So this is x minus 3 by 2 whole square minus a square. So this is this. Formula is x square minus a square, log x plus under root x square minus a square. So this formula will be used, and this is equal to log of, this will be 2x minus 3 by 2 plus this term is equal to this. So we can write this as x minus 1 into x minus 2. You can write this as this or this plus c. So this will be the answer. Now next is this. Here we have 5 minus 4x minus 2x square, and this can be written as minus 2x square minus 4x plus 5, and take minus 2 common to make the quotient of x square unity. So this will be x square minus minus plus 2x minus 5 by 2. Minus 2 has been taken common. So this will be x square plus 2x minus 5 by 2. And this is equal to minus 2 into integral of x square plus 2x plus half the quotient of x. Half the quotient of x is 1. So we will add 1 square and subtract 1 square minus 5 by 2. So this is equal to minus 2 into integral of x plus 1 whole square minus, this will be 2 minus 5, 7 by 2. This will be 7 by 2, and this can be written as minus 2 into integral of x plus 1 whole square minus root 7 by 2 whole square. And this is equal to, as I have told you earlier, you must always take this negative inside. So this must be written as root 7 by 2 whole square minus x plus 1 whole square. And now substitute in this and decide the appropriate formula. So this will be equal to, I is equal to integral 1 by root, now this term is equivalent to this, so this can be written as 2 into root 7 by 2 whole square minus x plus 1 whole square into dx, and this is equal to integral 1 by root 2. This 2 is common. 1 by under the root root 7 by 2 whole square minus x plus 1 whole square dx. This is 1 over under root a square minus x square. Now this is in the form 1 over under root a square minus x square. So its integration will be sine inverse x by a. So we will have 1 by root 2 into sine inverse x by a. X is x plus 1. X by a is root 7 by 2. This plus c, and this can be written as 1 by root 2 sine inverse root 2 by 7 into x plus c. This is the answer. So here we expressed this as difference of two squares and used appropriate formula, which is in this case sine inverse x by a. In this case it was log x plus under root x square minus a square. Now I will take two questions for root quadratic. So this is 3 minus 2x minus 2x square, and this can be written as minus 2x square minus 2x plus 3, and minus 2 is common, and we have x square plus x minus 3 by 2, and this is equal to minus 2 into x square plus x plus half the quotient of x. Half the quotient of x is half whole square will be added and half whole square will be subtracted. Minus 3 by 2. So this is equal to minus 2 into integral of this x plus 1 by 2 whole square minus. This is 1 by 4 and this is 6 by 4. So this will be 7 by 4. This is 7 by 4 and this is equal to, now take minus inside. This can be written as root 7 by 2 whole square. This is root 7 by 2 whole square and minus has been taken inside. So this will be x plus 1 by 2 whole square. Before using the appropriate formula, you must take this negative inside. So this is equal to I is equal to integral of under the root 2 into root 7 by 2 whole square minus x plus 1 by 2 whole square dx, and this is equal to integral, this root 2 will be common, root 2 into under root 7 by 2 whole square minus x plus 1 by 2 whole square dx, and this is equal to root 2 into, now appropriate formula for this will be a square minus x square. So this will be x, what will be the formula? Formula will be x under root of this by 2 plus a square by 2 into integration of its reciprocal, that is sine inverse x by a. So this will be x under root of this by 2 plus a square by 2 and integration of reciprocal is sine inverse x by a. You can see the side sheet. So this will be equal to x. X is x plus 1 by 2 whole square. X into under root of root 7 by 2 whole square minus x plus 1 by 2 whole square whole divided by 2. X under root a square minus x square by 2 plus a square by 2 plus root 7 by 2 whole square by 2 into integration of its reciprocal, that is sine inverse x plus half divided by root 7 by 2. Sine inverse x by a, and this can be simplified into LCM of this will be 2x plus 1 by 2 into under root of this. Now root 7 by 2 minus x plus 1 by 2, negative of this. So this is equal to 3 by 2 minus x square. So this can be written as, in short, as 3 by 2 minus x square. This term is this. This is equal to this. This is equal to this. This is equal to this. So 2 is common and rest is same. So minus will be taken inside. So this will be 3 by 2 minus x square whole divided by 2 plus root 7 by 2 whole square. This will be 7 by 4. 7 by 4 by 2 is 7 by 8. 7 by 8 sine inverse. Now LCM this is 2 and we have 2 here. So these two will cancel and we will have 2x plus 1 by root 7. This plus c. So what you should note is we have substituted this back from here. So this is half of this whole term. Half of this whole term. So half of this will be this. Now last question of this form is integral x minus x square dx. Now this is equal to x minus x square, which is equal to minus x square plus x, and minus is common, we have x square minus x, and this is equal to minus x square minus x and half the quotient of x. Half the quotient of x will be minus 1 by 2 whole square. Add half the quotient of x whole square and subtract half the quotient of x whole square. So this is equal to minus. Now this will be x minus 1 by 2 whole square. Minus half whole square is the same as half whole square. This negative I am taking only to indicate that b is negative. You can account for this negative from this term also. This is minus 2ab. So it should be negative. So this minus 1 by 2 whole square. And this is equal to, now minus will be taken inside. So this will be equal to 1 by 2 whole square minus x minus 1 by 2 whole square. And therefore this integral can be written as integral of under the root 1 by 2 whole square minus x minus 1 by 2 whole square dx. We have substituted this by this, and this is equal to, now formula for this will be a square minus x square. So a square minus x square is sine inverse x by a. So this will be x, that is x minus half into under root this term. So this will be 1 by 2 whole square minus x minus 1 by 2 whole square by 2. X plus under root a square minus x square by 2 and plus, because a square is positive. So this will be 1 by 2 whole square by 2. into integration of its reciprocal. So integration of reciprocal will be sine inverse x minus half over half x by a plus c. So this is equal to, LCM of this will be 2. So this will be 2x minus 1, and I am writing this 2 in the denominator. So this will be 4 into under the root 1 by 2 whole square minus this. This is equal to this x minus x square plus a 1 by 4 by 2 1 by 8 sine inverse. This will be 2x minus 1 by 2 over 1 by 2. So this will be 2x minus 1 plus c. So this is the answer. This is how you do questions of the type 1 over quadratic, 1 over root quadratic and root quadratic. Now I take up some questions which are reducible to the form we are discussing. So in this question we have cos x in the numerator. So if I put sin x equal to t, it will be cos x dx will be dt. So this will be dt and this will convert into t, and therefore this will be 1 by quadratic. So what we do is put sin x equal to t. So this will be cos x dx is equal to dt, and therefore I can be written as, if we denote this by I, this is equal to integral dt, cos x dx is dt, over t square plus 4t plus 5. Now we write this as sum or difference of two squares. So this can be written as t square plus 4t plus 5. This is equal to t square plus 4t and half the quotient of x, that is t. Half the quotient of this will be 2 square. So 2 square will be added and 2 square will be subtracted, plus 5. And this is equal to t plus 2. T plus 2 whole square minus 4 square plus 5. So this will be plus 1. And it can be written as 1 square. So I is equal to integral dt over t plus 2 whole square plus 1 square. So formula used will be dx over x square plus a square. That is 1 by a into tangent inverse t plus 2 by 1. Tangent inverse x by 1. So this is the answer, plus c. So this will be tan inverse and substitute t back. This is equal to tan inverse t is sine of x. Sine of x plus 2 by 1 plus c. So this is the answer. Now in this question what we do is, if a question is in the form integral f ex dx, function is in terms of the exponential, we generally try ex equal to t. Try this substitution. So here what we do is we put ex equal to t, and therefore ex, differential of ex is ex. Ex dx is equal to dt, and therefore I is equal to integral, this is dt over under the root 5 minus 4t minus t square. So this is this. Now what we do is we write this as 5 minus 4t minus t square is equal to minus t square minus 4t plus 5. Minus is common, so t square plus 4t minus 5. This is equal to minus t square plus 4t and half the quotient of t. Half the quotient of t is 2. So 2 square will be added and 2 square will be subtracted. So we get this, and this is equal to minus t plus 2 whole square minus 9, and this is equal to minus should be taken inside. So this will be 9 minus t plus 2 whole square, and therefore this integral I is equal to integral dt over, this is under the root 9 minus t plus 2 whole square. Then this is a square minus x square. This can be written as dt over under the root 3 square minus t plus 2 whole square. So dt over a square minus t square. So formula used will be sine inverse x by a. So this should be sine inverse t plus 2 by 3. This should be sine inverse t plus 2 by 3 plus c, and substitute t back. So this will be sine inverse e to the power of x plus 2 by 3 plus c. So this is how you reduce these questions into quadratic or 1 over root quadratic. Now next is this question. Now what we notice, differential of log x is 1 by x. So if I put log x equal to t, 1 by x dx will become dt, and this will be 16 plus t square. So this question will be solved. So put log x equal to t. So this will be 1 by x dx is equal to dt. I will solve this question very quickly. It is very simple. So I is equal to integral under the root, this can be written as 4 square. 4 square plus log x is t square into this is dt. And now you use appropriate formula, under root a square plus x square. So formula will be t under root this by 2 plus a square by 2 into integration of its reciprocal. Now formula for under root a square plus x square dx is x into this by 2 plus a square by 2 and integration of its reciprocal. So this will be t under the root 4 square plus t square by 2 plus a square by 2. A square by 2 is this into integration of its reciprocal. So integration of reciprocal of this. So integration of reciprocal of this is log x plus under root a square plus x square. So we have t instead of x. This plus c. Now substitute this back. So t will be log of x under root 16 plus log x whole square by 2 plus this is 16 by 2, that is 8. 8 log t is log x plus under the root 16 plus log x whole square plus c. So this is the answer. Now you can try these questions on similar line.